In this video, we'll look at some other ways to plot. So we've done rectangular coordinates, but we can also do polar coordinates and some other things. So after these notes here, let's create a new cell that's called, let's call it polar plots. So the command for plotting a polar graph is just the word polar, which is fun. Let's do this from 0 to pi in increments of pi 100ths. Don't need to see that in the command window. And let's call y sign values. And then we'll just polar xy. So let's run this section and see what we get. I get a nice circle, which is what you get in polar coordinates if the y value is equal to the sine of the angle. Excellent. So we've got whatever the first number is will be the angles, and whatever the second number is will be the radians. So that's fine. Well, let's keep going and do logarithmic plots while we're here. And I've lost that, so there we go. Logarithmic plots is a plot where the one or more of the axes are in a logarithmic scale instead of in a linear scale. This is very useful for things that have large differences between them. Let's give an example by doing x from 0 to 50 in increments of a half. And y will be, let's do 5x squared. 5 times x squared. There we go. Don't need to see that. Notice the dot in front of the exponent because x can be an array. In fact, x is a one-dimensional array, and I want to square each individual element, not do matrix multiplication. So let's use subplot as a refresher and to see multiple versions. So remember, we do this by saying subplot, and then we want to divide it into a 2 by 2, so I put those numbers first. In the first part of that grid, we will do just a regular plot of x and y. And then we'll shift our focus, still in a 2-2 grid, but shift our focus to the second place in that grid. That's what subplot does. Well, by the way, let's back up a step and put a title. Title, this is a polynomial with linear. That's the, we didn't make anything logarithmic there. So that's just a refresher. That's just straight up linear and linear. In our second subplot, we will plot, it's called semilog. Semilog x, and then in parentheses xy. So semilog x means only one of the axes will be a logarithmic scale, and I'm pretty sure it's going to be the x. Let's title this semilog x. So this is a log in the x direction and a linear scale in the y direction. We gave it a title. That's fine. Let's do the next one. Subplot 2, 2 in the third spot. Well, if we have semilog x, we can also have semilog y. So let's do that, xy. And we'll give that a title. Nothing tricky here. Semilog y, linear / log. So that way we get a linear in the x direction, log in the y direction. And then finally, in our last subplot grid, so still a 2 by 2, but now I'm shifting the focus to the fourth spot, I'll use the command, I've blanked, log. I love this one. Log is how we say we want logarithmic in both directions. So we want log, let's title that as a polynomial with log. Sure. So all of these are graphing the same polynomial, the same relationship between x and y. It's that 5x squared. The difference is the scale on the axes. So I'll show you how they change. Let us run this. It's going to do all of them at once, and I hope we get a nice picture. Let's run this section and see what we get. Oh, beautiful. So here's 5x squared. Here's the way it looks normally with a linear on both sides. It gets really big. This one has a logarithmic scale in the x direction, so it's really compressed out here and really stretched in the other areas. So what it's doing is it's either shifting or stretching is a better word because it's not keeping the same shape and just shifting it over. It's stretching out so that we get rapid changes for very high numbers. This one's a little, I was hoping we'd get more markations here, but you can kind of see there's little dashes. Those are the 10 to the power. So 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, and 10 to the power 5. So there's a lot, it looks a lot different. And you notice if we use a log, we actually get a straight line here. Is it really straight or does it just look straight? It's kind of hard to tell. I have a feeling it's not precisely straight. Anyway, depending on whether you use a logarithmic or a linear scale, you can make the graph look very different. So depending on what you want to see, you might want to stretch or compress the scale of your axes in different ways. So play around with them, decide which one is best for you and your particular needs at that time.